Lydia Olaka. She's a senior lecturer at the Technical University of Kenya in Nairobi in the Department of Geosciences. And she's an environmental geologist. And I've had the pleasure of being one of her supervisors as she was developing her career. And she has expertise in climate change adaptation and mitigation, geochemistry, groundwater flow, and dynamics. And she teaches both undergraduate and postgraduate courses. And she graduated from Potsdam University with her PhD in 2011, and she's a senior postdoc fellow in the Volkswagen Foundation Africa program. So she has made significant contributions in her areas of research, and there are quite many. Just look her up on the Google Scholar, and you will see some of the very recent research which have had a lot of impact globally. So she is quite well cited for the work which she has done. And so she is passionate about training the next generation through teaching, training, and mentorship. And she has also supervised a minimum of 15 masters and 2 PhD students along the way, and she's still moving forward. So with that, I'd like to just say welcome to Dr. Lydia Olaka to give us a presentation on the nature-based solutions and land degradation in the Savannahs. Welcome, Lydia.
Okay, thank you, Dan. Can you hear me well? Okay, so yes. Today the topic of my presentation is going to be centered on land degradation in the savanna and nature-based solutions for restoration. I'd like to share with you some of the insights that I have on this particular topic. I am a geologist by training, so I might have a little bit of a different take on it, but that is what is the topic of today's discussion. Okay. The second. Okay, so why is land degradation important? First of all, what does it mean? Land degradation refers to the many processes that drive decline of biodiversity, ecosystem functions, and also ecosystem services. This is according to the IPBES. And the issue is that when the ecosystem's functions decline, then a lot of things with it also suffer. Currently, 3.2 billion people are negatively impacted, and this equals to about 10% of the annual global gross product loss. And if I take a quote from the executive director of UNEP, he says that the unsustainable land use is scarring the earth for generations. It is costing us billions, impacting human health, and contributing to climate change. And this report from the IPBES actually it was a comprehensive effort to build credible scientific evidence. This was from the recent report that was shared on land degradation, basically trying to understand what is the status and what needs to be done. So land degradation, and especially when we look at the soils which are degrading, because when we look at land, we look at both the soil, the water, and the vegetation or the biota part of it. And soil degradation impacts on various sustainable development goals. These are the goals that countries have committed, 17 of them, to be able to achieve or get certain impact by 2030. For example, goal number 2 of zero hunger, soil health is very crucial in the agricultural productivity and food security. And also for SDG number 3, or healthy soils, will contribute to reducing hunger because the yields will be appropriate. So it will be able to contribute to reducing hunger and malnutrition, which also affect human health. And number 6, on water, soils play a very key role in water filtration and availability. And thus is important to address the issue of soil degradation. Soil also acts as a carbon sink. And now as the globe is actually looking at efforts to reverse the amounts of CO2 levels that are going into the atmosphere, soils act as a carbon sink. And if they are if they are degraded, then they release a lot of CO2 into the atmosphere, thus exacerbating climate change. So also, soil degradation threatens terrestrial ecosystem. This is in line with SDG 15, which is life on land, and biodiversity, and also land productivity. So addressing soil degradation is essential in achieving these sustainable development goals by ensuring ecosystem resilience, food security, climate mitigation, and also sustainable land use. So the topic for today is looking at the land degradation in the savanna. And the map that is presented now is if you look at the yellow part, that is where the savannas are. Basically, these are areas which are characterized by having grass and scattered trees, and they occur, as you can see, in all the continents, in majority of the continents. So we have in Africa, which is the main part, South America, Australia, and other parts of Asia. You can see where the savannas are. And savannas, they're usually shaped by fires. They are common fires, storms. The climate is seasonal. And then also there's wildlife disturbance because we have the megafauna in some of the areas that are able, especially elephants, which modify the trees of the area. And also they are also shaped by grazing pressures. So depending on the wildlife or the livestock that are in an area, they are able to modify the savannas. And many of the human activities that are happening on savannas will last for a period of days, weeks, or even months. But other factors may have a longer time impact or influence on the savannas. The African savanna biome, for example, is basically covers about half of Africa. So when we are talking about Africa, then this is an area that really needs to be addressed at the forefront, especially when we are looking at the future and the climate of the future, and also looking at the populations of the future. And the savannas also cover a fifth of the land surface of the world. In Africa, for example, it covers about 27 of the 54 countries. And the areas are areas where there's a daily temperature which ranges between 25 to about 30 degrees, but in some cases it might be a bit lower. But this is usually the areas that are covered by the savannas. So what are the ecosystem services which are gotten from these savannas, since they cover, for example, for the next couple of slides, I'll focus a bit on what's happening in Africa. The ecosystem services in the savanna are varied because this is where the communities are living. It helps in the biodiversity conservation. Savannas are very important for the wildlife and also for the bovine population, especially the livestock. Also, they're important for cultural services that are cultural identity for a number of communities who have lived and developed their livelihoods in the savanna. They're important also for carbon sequestration, as we mentioned, climate regulation as well, and they support the pastoral communities in the area. And so, and above all, they also are important for water regulation and provision of food. So the savannahs are provide the cultural, the provisional, the regulating and supporting services that we know of the ecosystems. So, but the topic for today is that they are degrading. And in many of the areas, especially when you look at the pictures from Africa, you will be able to see these kinds of areas where you have extensive land areas that have been degraded. And there are a number of studies that have shown where they're degraded. If we look at Africa, for example, if you just put your eye around here where the savanna boundary in the north is, you find that in most of the savanna area, it covers the erosion severity ranges between medium to very high. So it is something that really needs to be addressed. What are the causes? So I'll spend a bit of time. Mainly, what we have seen are the anthropogenic factors. Overgrazing comes up number one in many of the studies. Population dynamics as well, in terms of population growth, migration, and also refugees. These are also factors that have been cited as driving land degradation or soil erosion. And deforestation also, and reduction of vegetation cover. The deforestation happens from either looking for fuel wood or charcoal, or also using poles for construction and things like that. Also, there are traditional land uses. For example, the nomadism, shifting, transhumance, shift and cultivation, agriculture or tillage. These are all important for the communities that live in them, and in a way they are able to drive degradation. And this is very important, especially because prior to, these are traditional techniques. However, in many studies, it has been shown that during the colonial powers changed the land tenure system. And so for communities that were used to nomadism were forced to be sedentary. And some of the activities that we're doing when they stay in an area for a long time, especially when there's a lot of stock of animals and they're not able to move, then it leads to the land degradation or loss of the crop or grass cover, and eventually then we end up having soil erosion in the area because the animals kept beyond the carrying capacity. However, the choice of keeping of animals is a factor of other cultural dimensions. Then, of course, the political and socio-economical. So these are really most of the things that are cited. However, there are also natural, natural factors. Okay, something is missing there. There are a number of natural factors. I just want to mention them. The climate erosivity, for example, the amount of rainfall that is received in an area, the frequency, and also the wind velocity in an area. Those are biophysical factors that also determine land degradation. And vegetation, so the kind of vegetation, whether sparse or dense, the species diversity within an area, and also the root systems for the animals within the area are also factors. The soil erodibility is also another factor, which is natural. And soil erodibility is about the structure of the soil, the texture of the soil, infiltration capability of the soils, the organic matter within the soils, water retention, and also the amount of clay. So the interaction between the natural or the biophysical factors and the anthropogenic factors during the soil erosion process, these are the ones that determine the severity of degradation. And then the combination of both the anthropogenic and the natural or the biophysical factors determine the susceptibility of an area. And in many cases, I'd like to propose to you today that one of the areas that has not been looked into very much is the biophysical factors. And the biophysical factors that I want to focus on is especially soil erodibility. Normally, we have the sodic and saline salts in certain areas. And this map table from the FAO ITPS shows the area covered by these types of soils, which are problematic soils. And geographically, you can see for Africa, which is about the saline soils, about 122, covers around 122 million hectares. And the sodic soils in Africa are covering about 86.7. And this was the study basically used the expertise of a few soil scientists and the few studies that have been done to try and compile the extent of the sodic and saline soils in the various continents. The number for South Asia is a bit lower, and then we have the North and Central Asia as well, which is about 211, slightly a little bit more than Africa. And the highest here, it shows that it is within the Australian continent, which tends to be a little bit higher. And we have seen the reports or studies a lot in Southeast Asia, in Australia, on the soil degradation. What causes this? There are two ways. One is the rock weathering. So there's significant quantities of sodium in some, and to a lesser extent, chloride in some of the parent rocks in certain area. And over time, the rock weathering can lead to an appreciable amount of salt accumulations in the soil. And if leaching is restricted, this will happen. And also in other areas, we might have that rock weathering, which is primarily from sources where we have salt water. So infiltration from the subsurface as well can be able to cause saline or sodic soils. And in other areas, we also have the atmospheric deposition. So the atmospheric deposition, especially in land that is around the coastal areas, tend to increase or have a high quantities of salt across the area. There are also other human-induced causes, and the human-induced causes rely on basically management of land and water resources. It is responsible for developing the human-induced saline and sodic soils. And usually the main causes are because of poor drainage facilities, which induce a rise in groundwater table, and these may have a major cause on soil salinization. And this has been cited in a number of areas, such as India, Pakistan, but also Kenya as well. And the use of brackish water in some areas for irrigation, these can also cause secondary salinization. And there's also poor on-farm water management, especially because of cultural practices in irrigated land. And these are able to increase the amount of saline and sodic soils. So what is the problem? How does it look like? Usually from the top panel, when we look at the dispersed, the soils, which are really, especially the ones that crack during the dry season, these soils in many cases, they have the clays that do not allow it to flocculate. So in the end, when it rains, these particles, they disperse easily in the water. And you tend to find that these soils are the ones that have high sodium. So they are really they have a high sodium content in them, and they do not flocculate. And compared to the soils that have calcium and magnesium. And I put a picture here from the western part of Kenya. It's an area that is fairly covered in trees and also in grass for the better part of the year. And there's not much overstocking. However, the gullies are very, very extensive. And within a season, you can find the gully extending for over 20 meters in a very short time. And this is not even about the overstocking or deforestation that has been cited in a number of places. And this is within a savanna vegetation. So I propose that this is something that really needs to be looked into. What are some of the major or the emerging causes of land degradation other than what has already been cited as the human or anthropogenic? In the last decade or so, we have seen quite a high infrastructural development within Africa, and there are railway lines and roads that are all new through the savannah in areas which were not open before. And within a period of, this is a study which was done, and Professor Dan, who is hosting today, is a co-author as well. This was done by his postdoc student, and they were able to show that through the development corridor or the train track that you see up there, the erosion or the gullies developed in a very short time. We're talking about a time period of less than 5 years that the gullies were developing as a result of the construction of the road and also the railway line. At the bottom is another one where is also another railway line that is lifted, and when you look at it, the railway line at the bottom, it has actually modified the flow of the water in the area. So of course, really this new infrastructural development are causing ecosystem degradation and also fragmentation, because when the railway track passes through, and sometimes not very well constructed, that the wildlife can also migrate from one location to the other, then it will cause fragmentation of the ecosystem and also ecosystem destruction, as we can see from the soil here. Other things that are coming up also, I show you an area in Zambia, also within the savannah. On the right-hand side is an area which is called Lumwana, which has the red dot. And then on the left-hand side, you can see it in 20 years, how it looks like. And we see that these are very extensive area that has been cleared for mining. But it's not only mining that happens. Next to it, in the southern part, a town develops. And then there is people migrating into the area. So this is more or less like a trigger that then causes the degradation of the land in the area. And if we look, sorry about this, we are presenting from the PDF, and so some of the things are a bit hidden. I didn't put them side by side. Sorry about that. So as we can see here, the agenda for the next couple of years is basically to find critical minerals, and the global growth that is needed, or green transitions that are required, that is supposed to happen will require different kinds of minerals. And all of this, a majority of them actually are found in Africa. And like bauxite, chromium, cobalt, copper, etc. The mine that I showed you is actually a copper mine within the copper belt. And so when we are looking into the future, one of the key things that is going to be really key is mining. And of course, this is related to green transitions or trying to reduce carbon emissions into the atmosphere to reduce global warming. And for that, by reducing oil, then the various technologies have to be developed by using alternative minerals. And then this will only, again, come from these savannas. As you can see, this is a map from the RCMRG, which they've developed recently. And it shows quite a number of minerals in different areas all around Africa. The other thing also related with growth is quarrying. The infrastructural growth, development of roads, buildings, and bridges as well require dimension stones. They also require sand. And this is also another driver for land degradation and also soil erosion. This has been shown to trigger, unfortunately, there are not so many studies across the savannas within Africa that can quantify what exactly is happening. But there are anecdotal reports whereby the rivers or lakes which are within the catchments of, or which, where the quarries are within their catchment, are always have been shown to increase in their sediment load. Yeah. So this is something that needs to be watched out. So against that background, I want to suggest a few of the nature-based solutions which can be applied for restoration. There are a number of, for example, sustainable land management practices that need to be adopted, and these will help with the land, the soil, and also water conservation. And for this, when the sustainable land management practices are practiced, for example, they are able to prevent land conversion to and protect vulnerable lands. They are able to help with preventing and mitigating land degradation and also restoring degraded soils. They are also able to help with controlling soil erosion, also improve soil and water storage, manage the soil organic carbon, and also manage or increase the soil fertility, manage and enhance the soil fertility, promote also soil, crop, and water management, because that nexus is very important. The soil, the crop, and the water management, and also integrated agroforestry systems. With these sustainable land management practices, we can also be able to rehabilitate and sustainably manage dryland environments, e.g. managing grazing and also livestock, rainwater harvesting. There are also other techniques such as the sand dune reclamation in other areas that are marginal or in the vicinity of deserts. And the sustainable land management practices are also helping with the improving the crop and water productivity and manage the soil salinity, especially in the irrigated dryland agriculture. So I'm going to look at a few examples now. When it comes to the, one of the things that has since 2011 was the bond challenge that was launched by the government of Germany and IUCN in 2011. And the challenge was to first have about 150 million hectares of degraded land or deforested landscapes to be restored, and in 2030, and then 2020, but then by 2030 have about 350 million hectares of the deforested land being reforested. And the Great Green Wall Initiative that was started in relation with this, and this basically there are number of countries in the northern part and of the Sahel here. So we have the Sahel, but also in the Savannah part of Africa. And the countries have joined to combat the land degradation and also restore the native plant life to the landscape. And an expanse of about 15 kilometers wide and about 7,700 kilometers long has been set aside for this kind of restoration. And the project has since expanded to include a number of countries as well, in both in Northern and Western Africa. And the initiative uses an integrated landscape approach, which allows each country to address degradation, climate change adaptation, mitigation, biodiversity, and forest within its local context. And then specifically the African Forest Landscape Restoration Initiative, which is the AFR 100, is another country-led effort to restore 100 million hectares of degraded land across Africa by 2030. And this brings together African countries, donors, and technical experts to support the large-scale restoration projects to promote sustainable land management practices and also to enhance resilience to climate change. A number of very interesting initiatives have started. For example, there's the Seed Balls, Seed Balls Kenya, which is a company that has distributed a number of seeds. And what is interesting since 2016, and what is interesting about this is that the seeds are covered or coated in biochar, and they are dropped from any location by catapult, taxi, air, whatever it is. But the biochar coating protects the seeds from animals and predators and also birds, and also from extreme temperatures that some of these areas within the savannas experience. And the coating also protects the seed until you have the first rains, and then it provides a moist environment to encourage germination. So the biochar actually helps to keep the seed and then also provides some of the nutrients which have been used to help successful germination. This can be done for different kinds of seeds, has been done for different kinds of seeds, be it acacia, that is common within the savannas, or also the seeds of the grasses that are also important within the savannas. And the seed balls can be distributed at any time of the year, and you don't have to wait until the first rains. They can be distributed anytime. So the innovation here is basically looking at the temperature conditions that are experienced within the savannas now and also in the future, and also the fact that the nutrient conditions of many of the soils where the regeneration is required is also degrading. Then the biochar is able to provide that to the seed or to the growing, germinating plant until it is able to develop roots. And you can see from the different pictures on the right-hand side, what is happening. And about 37 million seeds have been distributed since 2016. So these are very good initiatives. And also recently, just I think on the 15th or a couple of days ago, this study that was done across Africa was looking at the commitments for restoration. And many of them, especially with the AFR project that plans to plant various trees or to reforest a lot of areas within Africa. The study is actually faulting this and saying that although they acknowledge that this is a good thing, many of the areas are mismatched. Some areas are not supposed to be forested. However, the mass forestation in many areas is also going to impact negatively on the ecosystems of these savannas. So there are concerns which are raised that the focus on tree-based restoration combined also with the misclassification of grassy ecosystems, because some of the grassy ecosystems were mapped or classed as degraded forest, yet they are supposed to be forested. So this is something that really needs to be looked into, because the grasslands are important for supporting the large populations of the livestock and wildlife that are grazers within the savanna ecosystem. The next solution that I'd like to mention is for restoring soil is what is known as enhanced rock weathering and various variants of it. What is this? Basically, this is whereby noticing the soils that are already degraded in terms of the nutrients or in terms of the quality, yet usually some of the rocks have the elements that are required. So the enhanced rock weathering, what it does is that it uses the mine wastes and rock that has no doesn't have a high value of toxins, and the minerals or rocks are crushed very finely, and these ones are transported and spread. The dust, which is about 2 millimeters or so, is spread over a large area within the field. It does two things. One, it helps with carbon dioxide sequestration, because the rocks that are used are those that have, especially basalt, which has divalent elements, the calcium and magnesium, and also iron that is required, that is able to bind with carbon when the rainwater, which is a dilute carbonic acid, reacts with it. And this, since in the last maybe 3 or 5 years, these kinds of projects have really increased, and there's quite a number of them. Many are still at the pilot stage, but there are several of them, at least here in Kenya, Tanzania, and also up in also in I think Senegal, in the southern part. This is being done. And this one also, so there's the carbon dioxide sequestration, so it helps with the carbon mitigation. The other thing that it's also able to do, because it converts the carbon dioxide into a water soluble bicarbonate in the soil, and through the enhanced rock weathering, the carbonate can flow into groundwater, or it flows back into the rivers, which is taken into the oceans, and it will be locked there for a longer time period. So it's really gaining popularity in the last couple of years, and there's a lot of funding as well on this. In addition, some of the trace metals which are not found within the soils that have already been degraded can also be found in the rock. And these specific rocks can be used to amend soils that are deficient of various metals like the molybdenum and boron. And there are studies. This has been built basically from the experimental study and a few pilots here and there. Brazil actually is a #1 leader in that type of technology. So the next, after the soils, what can also help restore the water systems on the ground and the water systems is basically the managed aquifer recharge. This is where the groundwater is replenished or recharged, added into using a managed aquifer recharge. This is a study that was done about 2 years ago, 4 years now, and it shows some of the areas where the managed aquifer recharge has been going on. One of them is South Africa. It has both the drier side and it also has the savannas. Then we have Kenya, so I'll only pick the ones with the savanna. We have also, there's also Nigeria and also Ethiopia. So all of them range and have different case studies of managed aquifer recharge. And this is done differently with different budgets. For example, the surface spreading is the most common one, where the water is spread over a large area and it can infiltrate, having known the properties of the subsurface. And then there's also where we have where there's open well or a shaft or a borehole where you can put in, you can inject water in. And then there's also the in-channel modification. So within rivers, these ones can also be modified in a way that water is recharged. And when there is more water within the soils of an area, then it will encourage the growth, or it will encourage the vegetation to occur in a specific area, and with that then reduces the soil degradation. I show an example here of a sand dam which was done. This is 2 pictures showing the before and also after. This is whereby a wall is made on the river and there's an impermeable or a clay layer at the bottom, so that when the water flows into the area, it cannot go over. It's only a small section. However, what is advantageous about this is that the water is covered also in the sand, and that reduces evaporation, which is a very key component in reducing the available water within the savannas. And as you can see, the difference in the vegetation growth over a period of about 7 years. So in conclusion, I'd like to say that there's need for a multidisciplinary approach to address landscape effect affected by severe degradation. Much of the studies has been focused on the ecosystems and modifying them, and also tree planting. And this requires much more, especially having the understanding of the soil properties, the climatic properties, the projected climate of an area, to be able to help in the restoration of the degraded lands. The other thing also is that tree planting initiatives can be administered. However, they have to be together with other soil restoration initiatives, especially in the areas that we have fragile soils, or we have soils that are either sodic or saline. Then also, enhanced rock weathering has a lot of potential to restore degraded areas. And this is something that is coming up because soils take a long time to regenerate. However, by this, the productivity of a lot of the areas is improved, and also the soil formation occurs much faster because the rock has been ground into finer particles. Okay. Then the other fourth conclusion that I put separately, I was really intrigued by this area because this is an area that has a gully that has developed for about 10 meters deep. It developed when in a savanna vegetation, when the trees and the grasses were already there. So the reforestation had actually happened. But because the soils are not known, they behave in a way that is very dispersive, together with other factors, then I think this is something that needs to be highlighted as a caution, that there are certain soils that would require special kind of management before focusing only on the plantation. And for the outlook, the predicted climate change and impact over the savanna shows that there's going to be changing weather patterns, and this has already been experienced, especially looking at the onset and cessation of rainfall, and also the extreme temperatures within that are experienced within a period of time. And for that, then I propose that the restoration activities that I've mentioned, which are considering these kind of changes, should be looked into or should be investigated for their potential use in different areas. Then also, one of the things that is really missing Africa-wide or in many of the countries is the monitoring of the soil erosion at different catchments. How much is eroding, at what rate? These are studies that really need to be put at the forefront. Or also the authority, there needs to be policy interventions that can, or regulations that can ensure that monitoring is something that is key together with the restoration. Of all this, the community must be involved, because when the community are involved, then they are also they're empowered with the knowledge that is required in a way that they can help with the land restoration. And there's also need to increase local funding. So I'm coming to the end, and that is the end. Thank you for listening.
Yes, thank you very much, Dr. Olaka, for that very nice and broad and interesting presentation. You've really covered a lot of areas, moving from the global perspectives and areas where we have similar kinds of issues. And you've also come in and looked at some of the initiatives which are taking place. The big emphasis on afforestation or vegetation restoration, which could be a buzzword, but for the savannas, it might actually be a kind of a maladaptation. So in essence, we need also to know the kind of ecosystems that we are beginning with. And then you went through many other different types of restoration methods, some which are very new, like the enhanced rock weathering, others which are very old and have been there for thousands of years, very effective, but we've forgotten them, like the sand dams, and they're coming back. And I think also very importantly, it's really important that we look at these scenarios going into the future. And, the tropical regions of the planet actually face a big challenge, because we really have to deal a lot more with extremes rather than the ends of extremes. So whether it's drought or flood, and all of these have really major impacts on our soils and vegetation. Yeah, so that was really very interesting and an eye-opener in many regards. We have a number of questions from the audience, and I think the first one that came in was from Arti Shah. And the question is, was the land degradation focused when the infrastructure projects were planned? I guess that one is relating to the SGR and the degradation that occurred as the galling that occurred as a result of that. So I'll maybe read 3 questions and then you can respond. The second one is from Julian Filsa, and she's asking, how can black biochar coating protect seeds from extreme temperatures? I think because they are black and black is a heat absorbent, maybe that doesn't come through very clearly. And then the third question is from Whitney, who said that you mentioned that few work have been done on biophysical factors. So does that mean focusing on anthropogenic factors to tackle soil degradation is more efficient for restoration? Does that mean that focusing on anthropogenic factors to tackle soil degradation is more efficient for restoration, as opposed to focusing on biophysical factors? So I think with those 3, you can respond, and then we can move on to any others that have been posted.
Okay. Thank you, everyone who has asked. I'm going to start from the last one, I think, which is on the focus on anthropogenic factors because the biophysical has not been done. I think it is not one or the other. When the main cause is the natural, especially as we can see the problem, there are quite a number of areas that you find degradation in a very, galling in a very short time period. We're talking about less than 5 years. And you actually find even trees that have been growing there and they are quite mature are also swept. So I don't think it is an either or. However, I think the natural must be mapped so that the interventions are appropriate per area, because not all the soils are the same. So there are some that would require more amendment than the others. Yeah. So it's not an either or. And actually, we've seen already there's quite a number of trees. I mean, when you hear about the number of trees that have been planted, it's in the area of billions. But up to now, we still see the kind of degradation that we have. So what is the problem? And I think it is the neglected study or the neglected knowledge that would help in together. So that is geochemists working together with ecologists and to be able to know, or foresters to be able to know what exactly is best for certain areas, and also the type of tree sometimes. But again, it has to be sort of one that is indigenous and is for the area, and not something that is going to be an invasive species. And then Julian asked about if the black, why the black char coating is helping. Yeah, this is very interesting as well, because it is actually mixed with other binders as well and conditioners. But what I've seen is that especially when they're being dropped by hand, then the recommendation is to put them in an area that is shaded. So usually they are put in an area that is shaded, or you cover it with a branch because it's an acacia, like the thorn ones, and they are covered, and with that, then they're not I think, of course, there might be 1 or 2. I don't know if there's any study in terms of the losses, but what it has shown clearly is that there's regeneration. So it seems like there's something that is happening. Yeah, that's what I'll say. And then the one for RT, it was about the land degradation focused. Was it focused? I didn't quite get it. Prof?
Yes. So yes. So in essence, was there a kind of a survey to say that there's a risk of land degradation if this infrastructure is coming through?
Yeah, I think all the studies carry out environmental impact assessment. All the major studies in Kenya, they carry out an environmental impact assessment, and based on that, which is mandatory, and based on that, the infrastructure goes ahead. Many a times, I think we have seen them going ahead anyway, so I'm really not sure what, did not look at the report on of this particular EIA, if it mentions something like that. But again, because this is in relation to Kenya, most of these studies on the sodic soils have only been done in the western part by ICRAF. These are the ones that they did quite a comprehensive study on. And so the areas like Naivasha, where, or the other areas which are all new areas for the infrastructure, these kinds of studies are not there.
Okay, thank you. Now we have just a few minutes left. So I'm going to push to you just 3 more questions, and then maybe also give very brief responses. After which, perhaps the other questions which are still in the chat could be answered later and then shared with the participants here, but Petra will let us know how we'll do that. So let me push to you these 3 questions, and then I'll go back to Petra to wind up. The first one is from Diego, who is asking, who notes that bush encroachment is an important form of degradation from the perspective of pastoralists. He also notes that bushes on savannas prevent soil erosion. So then the question is, what would a nature-based but socially sustainable restoration solution look like in this case? And then the second question, which is from Marcius, says, if you had unlimited financial resources, how would you use them for soil improvement? And then the last one is from Emmat, who asks, how can indigenous knowledge systems contribute to the sustainable management and restoration of degraded savanna landscapes? So if you can respond to each of those, 30 seconds at the most for each question, and then we shall hand over to Petra. Thank you.
Okay, thank you very much for everyone who has asked. The one for Diego on the bush encroachment, how it is very important, and what are some of the ways in which they can be used. I think the areas can be used sustainably. What I can say about this is basically that I think in the many of the historical literature or culturally, the way people in the savannah, savannas in many cases, people were either nomadic or carrying out transhumance. So they were not staying in an area for a long time. But because of the changes of the policies whereby there's acquisition of land and people are then pushed into smaller areas, these are some of the factors that are pushing that kind of soil degradation. So what can be done? I think some of the studies is basically that I've seen is usually to leave the areas to regenerate. So in a way that you have ranching similar to what was there previously, so that the land is left even for to regenerate and to recover certain species and the seeds that are within the soils to be able to recover. And then if I had a limited finance, what will I do for the soil improvement? I think I will find out where exactly I am at, because this really is site specific, because you need to know, first of all, what is the main factor that is causing it. So whether it is a topographic issue plus land use issue, or climate plus the soil chemistry, or it is a soil chemistry issue. So if it was a soil chemistry issue, then the first thing would basically try to amend the soils. So by using mostly gypsum and all the other things to balance the sodium, if that is the problem with the soil, so that we can be able to ensure that the dispersal of the soil does not occur. However, if it is a slope issue, that may be the topography of an area, there are no terraces and things like that, then that can be handled in a different way. So it could be that as well. How can the knowledge of the
if I may ask you just now to take 10 seconds, please, because we need to hand over back to Petra. 10 seconds to answer the
Indigenous knowledge, I
indigenous
think
question.
I covered it already in the beginning, so that's it.
Okay, thank you very much. Thank you very much for your responses. Back to you, Petra.
Thank you very much, Dan, and thank you very much, Lydia. Thank you for the exciting lecture and also for moderating the event today, Dan. As we see, we have a lot of questions here. We have another important topic that we debated and heard from you, Lydia, today. We unfortunately could not answer all the questions, but we are sorry for that. But as time is limited, we had to stick to a few ones there. You may also review the lecture as we put it online on our website again, so probably you find some answers to your questions there. And yeah, thank you both very much. We very much did enjoy the talk today. And before we close, I would like to invite you to join us again in the upcoming program of the lecture series. We have planned 2 more sessions currently for the first half of this year, and the next lecture will be on 15th April and will be given by Alberto Acosta, and he's a former Minister of Energy and Mines and the former President of the Constituent Assembly of Ecuador, and he will talk on transition studies and post-development. And we are very much looking forward to seeing you there. And yeah, have a nice day today and goodbye. And thank you very much for joining us today. And yeah, see you soon.